Welcome to the 5th grade Math Unit 6 PLC Deep Dive. My name is Susan Copeland and I'm one of the 6 elementary math curriculum specialists for CMS. I create CMS resources for 5th grade math. Today we will be taking a deep dive into Unit 6, More Decimal and Fraction Operations. As you dive deep into Unit 6, remember our goal is to support students to know mathematics deeply, to apply mathematics, and to enjoy mathematics. After watching this video, you will understand that when we convert from a larger unit of measure to a smaller unit of measure, we multiply because there are more of the smaller unit. And likewise, when we convert from a smaller unit to a larger unit of measure, we divide because there are fewer of the unit. You will understand that students add and subtract fractions with related denominators in 5th grade. That's halves, fourths, and eighths together, thirds, sixths, and twelfths together, fifths, tenths, and hundredths together. Understand that students should use area and length models to multiply mixed numbers. Okay, so let's get started. Here's our agenda for today. We will work through these sections today. On each title page, you will see the parts of the agenda through which we are working. Underneath the title, you will see the tasks that we will address in each section. Let's get started by accessing some important documents. First, you will need to log into NC Cloud and access Math Rocks. If you're new to CMS, the enroll code is on the screen and you can access Math Rocks that way. Once you're in Math Rocks, select 5th grade. On the 5th grade page, you can access the year at a glance, that's our scope and sequence, and the top right button. Then select Unit 6. You will find it on the Quarter 3 and 4 tab. Everything is in a folder in the Unit 6 link except for the curriculum guide. I will refer to the curriculum guide throughout the deep dive, so you may want to have that open. You will also need to access the note catcher using the bit.ly at the bottom of the screen if you haven't already opened it. Pause if you need to access these resources. Our first section is the unit overview on your note catcher. In this part of our deep dive, we will familiarize ourselves with the overarching story of the unit. We always want to begin a new unit by looking at the North Carolina Standard Course of Study aligned to the unit. The standards are located on slide 4 of the curriculum guide. NC 5 MD1, NC 5 NF1, and NC 5 NF4. You might also want to note that the first lesson in the unit revisits NC 5 NBT1 to prepare students to convert between units in the metric system. Click on the Post-it note on slide 3 of the curriculum guide or of the unpacking symbol at the bottom of the Math Rocks 5th grade page to get the unpacking document. Pause the video and take a moment to read and annotate or take notes about these standards using the unpacking document from pages 33 through 34, 23, and 26 through 29. I know those are out of order, but that's the order that they appear in the unit. I'm going to share a few things I noticed and would want to take note of before teaching this unit. You might have some other things that you noticed. I'm going to share my thoughts and you can share your thoughts too. When everyone shares what stood out to them, everyone gets a better picture of what's required in the standard. If someone says something that you didn't see or you have questions about, talk through it as a team, and you can reach out to me too. Let's start with NC 5 MD1 on pages 33 and 34 of the unpacking document. These standards didn't have a whole lot of print, but there sure was a lot of information in that small amount of print. First, students are given the conversion needed, so they don't have to spend time memorizing the equivalencies between units of measure. I also noticed that students use multiplicative reasoning, so students need to use multiplication and division to think about converting between units. And I noticed that students complete one-step conversions, but these conversions may be embedded in a multi-step problem. This just means that students won't be given 2 conversions to have to convert twice to complete. For example, if a problem asks how many millimeters in 3 meters and provided the information 1 meter equals 100 centimeters, and 1 centimeter equals 10 millimeters, then students would need to convert to centimeters first and then to millimeters. But that won't happen for students in 5th grade. Students will not need to experience that type of double conversion. If the problem wanted student to convert from meters to millimeters, it would say 1 meter equals 1,000 millimeters, for example. But students might have to add several numbers together before and after converting, as in this problem from unpacking, where the students must add 3 lengths in centimeters before converting to millimeters. I also noticed that students might encounter whole numbers, decimals, or fractions in these problems. Let's look at NC5NF1 next. Here's what I noticed. Students add and subtract both fractions and mixed numbers with unlike denominators. Even though the denominators are unlike, they are all still related. North Carolina specifically states that students add halves, fourths, and eighths together, thirds, sixths, and twelfths together, and fifths, tenths, and hundredths together. I will mention that sometimes students may end up adding thirds and fourths and twelfths together when they are multiplying in NF4. They're still all related because students can use twelfths to add and subtract. I also noticed that students should estimate to determine the reasonableness of answers. Students should solve 1- and 2-step word problems. Students should represent the problems with an equation. Students should solve problems using area and length models, so we're going to be looking for models. And students should apply their understanding of equivalent fractions to add and subtract fractions and mixed numbers. And last but definitely not least is NC5NF4. This is the 3rd unit that has addressed NF4 this year. In Unit 2, we multiplied a whole number by a fraction and a fraction by a whole number. In Unit 3, we multiplied 2 fractions. In this unit, students will use reasoning to explain why when a factor is less than 1, the product will be less than the other factor. When a factor is equivalent to 1, the product will be equal to the other factor. And when a factor is greater than 1, the product will be more than the other factor. Some things that I highlighted for this standard are as follows. Students multiply both fractions and mixed numbers. Just like with addition and subtraction, students use area and length models. When students multiply 2 fractions, the only denominators they use are halves, thirds, and fourths. Remember, that's why I said they might end up using twelfths if they end up with thirds and fourths in the answer. But if they're using models, they can also clearly see those parts in the model. Note that when students multiply a fraction or mixed number by a whole number, the denominator may be any of the denominators used in 5th grade. So if they're only multiplying 5 times 7/8, for example, it doesn't have to be 2, 3, or 4 if it's a whole number times a fraction. Students reason about products by considering if a factor is less than 1, equal to 1, or greater than 1. Students don't need to find the product, but rather make claims about the size of the product. We will look at an example of this later in this session. Word problems for the standard are 1 step. Okay, so that wraps up our new standards. Let's move to summarizing the unit on your note catcher. We'll look at the summary at the beginning of the lesson notes in your curriculum guide. Read the unit overview on slides 9 and 10 in your curriculum guide. When you finish, try to summarize the gist of the unit in a sentence, or 2 maybe. This one is a big one. Then discuss with your team how the unit follows the design elements of invitation, deep study, and consolidation. Pause the video to complete this task. In this unit, students solve multi-step problems involving measurement conversions and addition and subtraction of fractions and mixed numbers with unlike denominators. For measurement, students solve problems including fractions and decimals. Students explain and apply patterns when multiplying and dividing by powers of 10 with metric conversion problems. Interpret multiplication as scaling by comparing products with factors, and use area and length models to multiply mixed numbers. Now let's think more specifically about how standards and targets build across the sections of the unit. unit. This unit is separated into 3 sections. Read the section overviews on slides 12 through 14 of the curriculum guide. Then look at the 8 task cards taken from the units on slides 5 through 12. Slide each task to be below the section within which it falls. Talk in your PLC about how you decided which section each task belongs within. How does each task support the goals of the section? Pause the video now and return after completing this sort. Here are the sections with the aligned cards. Cards B, I, and E are cooldowns in Section A. This section focuses on measurement conversions. The section begins with NBT1 work multiplying and dividing by powers of 10. This prepares students to convert metric length, mass, and capacity units in the next few lessons. Students both multiply to convert to smaller units and divide to convert to larger units. Many of the activities in this section include decimals. Following metric conversions, students multiply and divide to convert customary units. The work in this section also includes work with fractions. Cards G, H, and A are cooldowns from Section B. Students add and subtract fractions and mixed numbers with unlike denominators. Students move from fractions to mixed numbers and from situations in which composing a whole is necessary when adding or decomposing a whole when subtracting. Cards D, F, and C are cooldowns from the Section C. This section focuses on reasoning about products using one factor and on multiplication of mixed numbers with an area model. Let's do a little math now. Read the learning goals for each section and try these tasks located on your note catcher. How do these tasks support students with understanding the goals of each section? What strategies might your students use? Pause the video now and try each of these tasks. Let's take a quick look at each of these tasks you just completed. The first task is from Section A, Lesson 4, Cooldown. Student C, Jada, ran 15 and 25/100 kilometers and Han ran 8,500 meters. Since we have one length, or typically referred to as distance when traveling, in kilometers and the other in meters, we need to convert one or the other to compare. We also see in the problem that 1 kilometer is equal to 1,000 meters. Since most students prefer to multiply, let's multiply to change Jada's 15 and 25/100 kilometers into meters. To multiply 15 and 25/100 by 1,000, we need to shift the digits 3 places to the left because the number is getting larger, since it will take more meters than kilometers to measure the distance. That will place the last 5 in the tens place where the 1 is now. So 15,250 meters is how far Jada ran. Question also asks who ran further and how much further. So now I'm going to compare Jada's meters to Han's meters. I see that Jada is 15,250, so hers is greater, and Han's is 8,500. His is less. To find the difference, I'm going to subtract. That gives me 6,750 meters more for Jada than Han. Note that I can also change that into kilometers, and it would be 6 75/100 kilometers. Our second problem is from Lesson 7. I only chose 2 of the 4 problems, Problems 2 and Problems 4, to highlight an important idea in this section. In the first problem, the Rodriguez family had 6 cups of one kind of punch and 9 cups of another kind of punch. The question asks about how many quarts that is. We are given that 1 quart is equal to 4 cups. So we are moving from the smaller unit cups to the larger unit quarts. Since we are converting from a smaller unit to a larger one, we will have fewer of that unit, which means that we divide. 15 divided by 4. We can also solve this by drawing out fourths until we have 15 fourths, which will be 3 wholes and 3/4 of another whole. Or we can record as an improper fraction 15/4, since we know the relationship between division and fractions now, and then find the value. Either way, it's going to be 3 3/4. In problem 4, we see that Jaquan has 2 3/4 gallons of tea. We are converting into pints. We see in the problem 1 gallon equals 8 pints. Since pints are smaller than gallons, we will have more pints than gallons. So we multiply 2 3/4 times 8. Let's use the distributive property and multiply 2 times 8 and add that to 3/4 times 8. That would be 16 plus 24/4. And 24/4 is 6, so it's like 16 plus 6. So 16 plus 6 is equal to 22. So our answer is 22 pints. Our next task comes from section B and requires reasoning about another student's work. Students should notice that Miguel was able to remove the 2 holes, but it was a little trickier to remove the 5/6. This required first changing the thirds to 6 by partitioning, showing that 4/6 could be removed. But since Miguel needed to remove 5/6, he had to decompose a whole into 6/6 and then remove 1 more 6. So he was left with 1 whole and 5/6. Students should notice that Miguel is using X's to mark out what was removed, just like with the whole number in lower grades. Equivalent fractions had to be used to change from thirds to 6, and a whole had to be decomposed. It was decomposed into 6 because it was 6 that you need removed. You might consider connecting this to expressions that show what's happening. The first problem is 4 2/3 minus 2 5/6. We can remove the 2. 4 2/3 minus 2, and then what we had left was 2 wholes and 2/3. Then we needed to subtract 2 2/3 minus 5/6, because we still have to remove the 5/6 part. But now we need a common denominator. So we partitioned our model so that we had 2 4/6 minus 5/6. But that's still not enough 6 to subtract, so we needed to decompose a whole into 6, since that is what we need. So now we have 1 whole and 10/6 minus 5/6. Now we can subtract, and the difference is 1 5/6. We're going to look at 2 activities in section C. The first activity is Unit 6, Lesson 18, Activity 1. This task is scaling one factor by the other one. Students do not need to actually solve to find the exact distance to determine the shortest and longest distance. In solving this, the first thing I noticed is that Kieran is the only one that ran the trail more than one time. So Kieran's distance must be the longest distance. Noah and Elena both ran less than the whole trail. But half of the trail is less than 3/4 of the trail. So Noah ran the shortest distance and Elena ran the middle distance. Let's look at problem 2 now. Problem 2 has us think about other children and record an answer. Answers may vary on this one, but we want to use the same logic. Let's go ahead and place Elena, Kieran, and Noah on a number line. All of the statements are in reference to the whole 5-mile trail. Diego ran further than Noah, but not as far as Kieran. So he would be in this section that's highlighted yellow. We could place Diego here, for example. And if Diego was here, we would say that he ran 3/4 of the trail. Lynn ran farther than Kieran, but not twice as far as Kieran. So we know Lynn would be somewhere in this section. We could choose anywhere, but let's choose right here. So if he ran further than Kieran, he may have run. We can see it's past 1 whole, and we're still partitioned in fourths. So it would be 1 2/4, or we could call that 1 1/2. Tyler ran further than Noah, but not as far as Elena. Ooh, this one is tricky because it's right in the middle and there's not a tick mark. So what we're going to need to do on this one is repartition from 0 to 1 each fourth into 2 equal parts. So if I partition each fourth in half, I take fourths and I'm folding them in half if I'm using paper. Now I have eighths. And so I could say from 0 to 1 there are 8 sections, and if I count, Tyler is now at 5/8. So Tyler ran 5/8 of the 5-mile trail. Now let's look at problem 2 from section C. The first 4 lessons in section C focus on scaling, what we were just talking about, and we're going to talk more about that in just a moment. But the second part of the unit focuses on multiplying mixed numbers of section C. So let's look at problem 1 first. In this problem, students find the area of a park that has a length of 2 1/4 miles and a width of 1 2/3 miles. So using area equals length times width, we need to multiply 1 2/3 times 2 1/4. We can use an area model to solve this problem. Graph paper can be used to make a rectangle that is 2 1/4 units long and 1 2/3 units wide. Then we can decompose both dimensions by separating the whole number and the fraction. I'm doing that with green right here. Now, just like with whole numbers, we can find the area of each partial product. So I just labeled them A, B, C, D, so I made sure I would get each one. So if I look at A, that section is 1 by 2, so it's 2 units. B is 1 by 1/4, which is 1/4 units. C is 2/3 by 2, which is 4/3. I can rewrite that as 1 1/3. And D is 2/3 by 1/4, so I can write that as 2/12. I'm going to leave that as 12ths because it's going to be important that I have 12ths to add to fourths and thirds. Okay, so now I have 4 partial products. I'm going to add all of those partial products together. 2 plus 1/4 plus 1 1/3 plus 2/12. But the problem is that I don't have like denominators. Because all of these fractions are related using 12ths, we're going to use 12ths. And I can change 1/4 to 3/12 using equivalent fractions, 1 1/3 to 1 4/12, and 2/12 is already in 12ths. So that would be equal to 3 9/12. Or I can use an equivalent fraction to rewrite that with smaller numbers as 3 3/4. Let's look at problem 2 now. This one is talking about a square that is 2 1/2 yards on each side. Since it's a square with a side length of 2 1/2 yards, that means both the length and the width are going to be 2 1/2. So we can multiply 2 1/2 by 2 1/2 to solve this problem. We can use an area model again. So I'm representing this as 2 1/2 and 2 1/2 on graph paper. I'm going to partition the sections again into A, B, C, and D. This time section A is 2 times 2, which is 4. Section B is 2 times 1/2, which is 2 halves if I'm using repeated addition, but I could also just see that that is 1. Section C is 1/2 of 2. What is half of 2? 1. And section D is 1/2 times 1/2. This is the part that might be a little bit tricky, but we worked on this in Unit 3. So students can see in our diagram that in the D section, in that one hole that's shown with the black graph paper as a whole, there are 4 equal parts and one of them is shaded. So you can see that it's 1/4. Some students have already begun to develop the algorithm and know to multiply across from multiplying fractions, but it's also important that they take a moment to look at it in the diagram to understand why the diagram does make sense. Okay, so then we just add those partial products together. 4 plus 1 plus 1 plus 1/4 is a little bit easier this time because we didn't have any unlike denominators, and the product is 6 1/4. All right, now we're going to do a little bit of backwards planning. Looking closely at the end of unit assessment before teaching the unit will deepen your understanding of what students need to know and be able to do by the end of the unit. Assessment resources are located on slide 6 of the curriculum guide. This unit has 2 assessments because units 5 and 6 are both very long, and it would have only allowed 1 formal grade in quarter 3 if the assessment had not been broken into 2 parts. The Section A assessment addresses measurement, found in lessons 1 through 8, and the Section B assessment addresses addition, subtraction, and multiplication of fractions and mixed numbers. If you haven't already taken the assessments, take a moment to complete the items. Since we know all items on the first assessment are from Section A, consider these descriptors as you work. These are some of the things that I considered as I was creating the assessment. And for BC assessment, the descriptors are a little different, but things that were considered as the test was created. When you finish, share your thoughts about what students may do well on and what they may struggle with. What are some misconceptions that may come up? This is a great time to learn from the experience of your team. Pause the video now and return after you finish the assessment in these charts. Okay, here's a quick look at where I landed for Section A assessment. You might notice that there are more smaller to larger items. This is intentional because students in 4th grade converted from larger to smaller. 5th grade is the first year where students convert from smaller to larger. You will also notice that many of the items included fractions or decimals to reinforce work with fractions and decimals earlier this year. Okay, here's a quick look at where I landed for Section BC assessment. Notice that there is a wide variety of the types of add-ins or factors, and many of the items require reasoning. Save and use this document as you review student performance on these assessments at the end of Section A and Section C. You may notice trends that help you address misconceptions for specific students. Let's think through part of a lesson together. For our lesson today, I selected several parts from 4 lessons in Section C. These lessons build student understanding of scaling of one factor. Let's take a look at the progression. We'll start with Activity 1 in Lesson 18. This is the activity that we looked at earlier. It's one of the first experiences students have with scaling. Students might tackle this problem by multiplying or reasoning about fractions. The goal in this lesson is that students move toward reasoning. We're not going to redo this task right now since we already looked at it. I just wanted to start here because this is the initial work of this section. In Lesson 19, students compare the size of a product to the size of one factor on the basis of the size of the other factor, without performing the indicated multiplication. In this activity, students order the distance run by a group of students. This is similar to the Lesson 18 activity. However, this time students don't have a number for Priya. Priya's distance is represented on the number line, and the other students must be placed on the number line based on Priya's spot. Take a minute and try this task. Explain how you know where to place each student on the number line. Pause the video and try this one. Here is where I landed. Talk it over with your PLC. Do you agree? In Lesson 20, students continue the same work without context. Let's look at Activity 1, Approximate Location. Students label expressions on a number line only labeled with 12. Then students determine what the numerators and denominators would need to be to make a statement true. And then in Activity 2, the number becomes an unknown with the letter A. Please note that students should not be multiplying these fractions. Pause the video and try these tasks. 1/4 times A would be 1/4 of the distance to A, for example. 2 times A would be double the distance of A from 0. Since 13/8 is 1 5/8, it would be a little past the middle between A and 2 times A, and 2/3 times A would be 2/3 of the way between 0 and A. At the bottom, students do not need to multiply these again, but they're determining if it's less, greater than, or equal to 34/100ths. Since 13/8 is more than one group of 34/100ths, the answer would be greater than. 13/8 times 34/100ths is greater than 34/100ths. And 2/3 times 89 hundredths is less than 89 hundredths because 2/3 is less than one group of 89 hundredths. And for the final lesson focused on scaling, students use expressions, number lines, one whole, and the distributive property to prove their reasoning is true. Let's look at activity 1. Match A, B, and C to an expression on the right that shows how the distributive property could prove that the first factor is more or less than one of the second factor. Then find the matching number line with the expression marked. Pause the video now and press play after you have completed this problem. Here's where I landed. Notice that 2/5 times 4/3, we're thinking about 2/5 first. 2/5 is 1 minus 3/5 times 4/3. So that is showing us that that is less than 4/3 because it's less than 1 of 4/3. Students are asked to explain one of them. I chose to explain A down at the bottom. So for example, in A, 2/5 is less than 3/5 less than 1. So for the product of 2/5 times 4/3 to be greater than 4/3, it would have to be more than 1 times 4/3. But the second expression shows that 2/5 is less than 1, and it would be less than half of 1. So number line C shows the expression as less than half of 4/3. Let's wrap up our time today with some key points and next steps. Just as a reminder, when we convert from a larger unit of measure to a smaller unit of measure, we multiply because there's going to be more of them. It takes more centimeters to measure an area than meters. Likewise, when we convert from a smaller unit to a larger unit, we divide because there's going to be fewer. So if I measured the length of a table in centimeters and then I measured the same length, the same table in meters, I'm going to need less meters because meters are bigger. We also need for students to add and subtract fractions with related denominators. This just means that they are always going to be changing one of the fractions to the denominator to an equivalent fraction with a denominator of one of the other fractions. So it will never be in 5th grade where they have to change to a denominator that is not already in the problem. Understand that students should use area and length models to multiply mixed numbers. We want students using models to multiply. It's really important that students are making sense of what is happening. And what are your next steps? As you're planning, use the daily lesson notes to follow along. It tells you what lesson it is in the book, but you really don't have to worry about that now because, yay, you're going to have your own workbook. So the workbook lessons in your new workbook will match the lessons here, and it's going to be like that all next year. So I appreciate all of you who have been emailing or who have been putting on the feedback form that they don't match, but we were trying to get it ready for the workbook that we're going to use next year, so it will be fully aligned to the North Carolina Standard Course of Study next year. Okay. Those lesson notes you can look are on slides 17 through 29, and that will get you to all of the information you need for each daily lesson. Thank you for attending this virtual course. Please email any questions to me, Susan Copeland, at the email on the screen, which is also linked on the 5th grade Math Rocks page. If you have any feedback about resources or corrections that are needed, please use the link at the bottom of the 5th grade math page because we are trying to make sure everything is corrected for next year. Thank you so much, and I hope this video was helpful for you.